extension was added and new target-style thrust reversers were incorporated. The thrust reverser doors were set 35 degrees away from the vertical to allow the exhaust to be deflected inboard and over the wings and outboard and under the wings. The improvement became standard on all aircraft after March 1969, and a retrofit was provided for active aircraft. Longer nacelle forward/wing fairings were introduced, and the airflow over the flaps and slats was improved. The production lineal SU introduced an improvement to the flap system, allowing increased use during takeoff and landing. All these changes gave the aircraft a boost to payload and range, and improved short-field performance. 15. 737-200. The 737-200 was a 737-100 with an extended fuselage, launched by an order from United Airlines in 1965 and entered service with the launch customer in April 1968. Its unit cost was $4.0 m, 1968, 26, $31.2 million today. The -200's unit cost was $5.2 m, 1972, $33.7 million today. The 737-200 Advanced is an improved version of the -200, introduced into service by All Nippon Airways on the 20th of May, 1971. 22. After aircraft #135. The 737-200 Advanced has improved aerodynamics, automatic wheel brakes, more powerful engines, more fuel capacity, and hence a 15% increase in payload and range over the original -200s and the 737-200 was brought into service by United Airlines on April 28, 1968. Several Canadian airlines still use the 737-200 due to its gravel runway capabilities. The Boeing unpaved strip kit, gravel kit, included a gravel deflector on the nose gear and a vortex dissipator extending from the front of the engine. Respectively -100s. 17, 31. The 737-200 Advanced became the production standard in June 1971. 32. Boeing also provided the 737-200C Combi, which allowed for conversion between passenger and cargo use, and the 737-200QC, Quick Change, which facilitated a rapid conversion between roles. The 1,095th and last delivery of a -200 series aircraft was in August 1988 to Human Airlines. 1. 33, 19737-200s. Designated T-43, were used to train aircraft navigators for the U.S. Air Force. Some were modified into CT-43s, which are used to transport passengers, and one was modified as the NT-43, a radar test bed. The first was delivered on the 31st of July, 1973, and the last on the 19th of July, 1974. The Indonesian Air Force ordered 3 modified 737-200s designated Boeing 737-2X9 Surveyor. They were used as maritime reconnaissance, MPA, forward/transport aircraft, fitted with SLAMMAR, side-looking multi-mission airborne radar. The aircraft were delivered between May 1982 and October 1983. 34. After 40 years, in March 2008, the final 737-200 aircraft in the U.S. flying scheduled passenger service were phased out with the last flights of Aloha Airlines. 35. As of 2018, the variant still saw regular service through North American charter operators such as Sierra Pacific Airlines. 36. With the improved short-field capabilities of the 737-200, Boeing offered the option of the gravel kit modification features preventing foreign object damage, which enables this aircraft to operate on remote, unimproved or unpaved runways, such as gravel runways, that other similarly sized jetliners cannot. 37, until retiring its -200 fleet in 2007, Alaska Airlines used this option for some of its Combi aircraft rural operations to serve many unimproved runways in Alaska. 38, 39. Gravel-kitted 737-200 Combis are still used by Canadian North, which is due to retire their last one in early 2023. 40. Air Inuit, Nolina Aviation and Crono Aviation in northern Canada, where gravel runways are common. As of October 2020, there were 77 Boeing 737-200s in service. 41. 737 Classic, second generation. The Boeing 737 Classic is the name given to the 737-300/400/500 series after the introduction of the -600/700/800/900 series of the Boeing 737 family. 42. Produced from 1984 to 2000, a total of 1,988 Classic series were delivered. 43. Close to the next major upgrade of single-aisle aircraft at Airbus and Boeing, the price of jet fuel reached a peak in 2008, when airlines devoted 40% of the retail price of an air ticket to pay for fuel, versus 15% in 2000. 44. 45. Consequently, in that year, carriers retired Boeing 737 Classic aircraft to reduce fuel consumption. Replacements consisted of more efficient 737 Next Generation or a 320 family aircraft. On the 4th of June, 2008, United Airlines announced it would retire all 94 of its Classic 737 aircraft. 64 737-300 and 37-500 aircraft, replacing them with a 320 family jets taken from its TED subsidiary, which has been shut down. 46, 47, 48. This intensified the competition between the two giant aircraft manufacturers, which has since become a duopoly competition. An optional upgrade with winglets became available for the Classic ending series. The 737-300 can be retrofitted with aviation partners. Boeing winglets. The 737-300 retrofitted with winglets is designated the -300 SP, Special Performance. WestJet was to launch the 737-600 with winglets, but dropped them in 2006. 49. 737-300. 737-300 with wider CFM56 turbofans introduced by US Air on November 28, 1984. Development began in 1979 for the 737's first major revision, which was originally introduced as the new generation of 737. Boeing wanted to increase capacity and range, incorporating improvements to upgrade the aircraft to modern specifications, while also retaining commonality with previous 737 variants. In 1980, preliminary aircraft specifications of variant, dubbed 737-300, were released at the Farnborough Airshow. 51. This first major upgrade series was later renamed 737 Classic. It competed primarily with the MD-80, its later derivative the MD-90, and the newcomer Airbus A320 family. Boeing engineer Mark Gregor led a design team, which cooperated with CFM International to select, modify and deploy a new engine and nacelle that would make the 737-300 into a viable aircraft. They chose the CFM56-3B1 high bypass turbofan engine to power the aircraft, which yielded significant gains in fuel economy and a reduction in noise. Butte also posed an engineering challenge, given the low ground clearance of the 737 and the larger diameter of the engine over the original Pratt & Whitney engines. Gregor's team and CFM solved the problem by reducing the size of the fan, which made the engine slightly less efficient than it had been forecast to be, placing the engine ahead of the wing, and by moving engine accessories to the sides of the engine pod, giving the engine a distinctive non-circular hamster pouch air intake. 52, 53. Earlier customers for the CFM56 included the U.S. Air Force with its program to re-engine KC-135 tankers. 54. The passenger capacity of the aircraft was increased to 149 by extending the fuselage around the wing by 9 feet 5 inches, 2.87 m. The wing incorporated several changes for improved aerodynamics. The wingtip was extended 9 inches, 23 centimeters, and the wingspan by 1 foot 9 inches, 53 centimeters. The leading edge slats and trailing edge flaps were adjusted. 52. The tail fin was redesigned. The flight deck was improved with the optional EFIS, electronic flight instrumentation system, and the passenger cabin incorporated improvements similar to those developed on the Boeing 757. 55. The prototype -300, the 1,001 ST-737 built, first flew on February 24, 1984, with pilot Jim McRoberts. 55. It and 2 production aircraft flew a 9-month-long certification program. 56. The 737-300 retrofitted with aviation partners winglets was designated the -300 SP, Special Performance. The 737-300 was replaced by the 737-700 of the next generation series. 737-400. The 737-400 was launched in 1985 to fill the gap between the 737-300 and the 757-200. In June 1986, Boeing announced the development of the 737-400, 57, which stretched the fuselage a further 10 feet, 3.0 m, increasing the capacity to 188 passengers, and requiring a tail bumper to prevent tail strikes during takeoff and a strengthened wing spar. 58. The -400's first flight was on the 19th of February, 1988, and, after a 7-month forward/500-hour flight testing run, entered service with Piedmont Airlines that October. 59. The last 2 -400's, i.e. the last 737 Classic series, were delivered to CSA Czech Airlines on the 28th of February, 2000. 60. The 737-400 was replaced by the 737-800 of the next generation series. The 737-400 SF was a 737-400 converted to freighter, though it was not a model delivered by Alaska Airlines. Was the first airline to have a 737-400 converted to a freighter. Boeing and hence the nickname Special Freighter, SF. Alaska Airlines was the first to convert one of their 400s from regular service to an aircraft with the ability to handle 10 pallets. 61. The airline had also converted 5 more into fixed combi aircraft for half passenger and freight. These 737-400 combi aircraft were retired in 2017 and replaced by the 737-700F of the next generation series. 62. 737-500. Shorter by 7 feet 10 in, 2.4 m. The first 737-500 was delivered to Southwest Airlines on the 28th of February, 1990. The 737-500 was offered as a modern and direct replacement of the 737-200. It was launched in 1987 by Southwest Airlines, with an order for 20 aircraft, 63, and it flew for the first time on the 30th of June, 1989. 59. A single prototype flew 375 hours for the certification process, 59, and on the 28th of February, 1990, Southwest Airlines received the first delivery. 43. The -500 incorporated the improvements of the 737 Classic series, allowing longer routes with fewer passengers to be more economical than with the 737-300. The fuselage length of the 737-500 is 1 foot 7 inches, 48 centimeters, longer than the 737-200, accommodating up to 140, 58 passengers. Both glass and older-style mechanical cockpits arrangements were available. 59. Using the CFM56-3 engine also gave a 25% increase in fuel efficiency over the older 737-200 SP and engines. 59. The 737-500 has faced accelerated retirement due to its smaller size, after 21 years in service compared to 24 years for the -300. 64, 65. While a few 737-300s were slated for freighter conversion, no demand at all existed for a -500 freighter conversion. The 737-500 was replaced by the 737-600 of the next generation series, though the -600 was not as successful in total orders as the -500.737 ing, third generation. The Boeing 737 Next Generation, abbreviated as 737 Next Gen or 737 ing, is the name given to the main model 737-600/700/800/900 series and the extended range -700/900 variants of the Boeing 737 family. It has been produced since 1996 and introduced in 1997, with a total order of 7,097 aircraft, of which 7,031 have been delivered as of May 2019. 23. The primary goal was to re-engine the 737 with the high-pressure ratio CFM56-7. By the early 1990s, as the MD-80 slowly withdrew from the competition following the introduction of the MD-90, it had become clear that the new A320 family was a serious threat to Boeing's market share. Airbus won previously loyal 737 customers, such as Lufthansa and United Airlines. In November 1993, to stay in the single-aisle competition, Boeing's board of directors authorized the next generation program to mainly upgrade the 737 Classic Series. 66. In late 1993, after engineering trade studies and discussions with major customers, Boeing proceeded to launch a second derivative of the Boeing 737, the 737 Next Generation, Ing. -600/700/800/900 series. 1. It featured a redesigned wing with a wider wingspan and larger area, greater fuel capacity, longer range and higher MTOs. It was equipped with CFM56-7 high-pressure ratio engines, a glass cockpit, and upgraded interior configurations. The four main models of the series can accommodate seating for 108 to 215 passengers. It was further developed into additional versions such as the corporate Boeing business jet, BBJ, and military P-8 Poseidon aircraft. Following the merger between Boeing with McDonnell Douglas in 19